Welcome to 3M training. We will go over the different tapes and adhesives that we sell through 3M, primarily the tapes that are sold through 3M's industrial adhesive and tape division, which is the vast majority of what we sell from 3M. This is the adhesive and tape continuum. What it outlines is the different strengths of the different tapes and adhesives that 3M has. 3M defines structural as being 1000 psi or greater. As you can see on this chart, you start out with adhesive transfer tapes, double coated tapes, which are the weakest as far as strength goes. As you move up the continuum, contact spray adhesives, you add a little more strength. Once you start hitting acrylic foam tapes and hot melt adhesives, you gain even more. Adhesive sealants, PUR adhesives, and structural adhesives are going to give you your greatest strength on this continuum.
An important topic when it comes to bonding is surface energy. Surface energy is measured in dynes per centimeter, and all of the substrates that we work with will have a specific surface energy. Low surface energy materials are typically materials that are very difficult to stick to, which you can see on the slide here. High surface energy materials are materials that are very easy to stick to. So as you see, that water droplet hitting the high surface energy material on the left-hand side, it easily wets out over the surface. Think of that droplet as an adhesive. It's easily able to wet out on that high surface energy material. And high surface energy materials are typically natural materials like glass and metals. On the other side, your low surface energy material is a material that is challenging to stick to. So when that water droplet hits the surface, it almost wants to bead up and attach to itself more than it wants to wet out over that surface. Some examples of low surface energy are polyethylene plastics, polypropylene plastics, composite materials, and some paint systems like PVDF, Kynar paint systems, and powder coat paint systems that are very typically used on aluminum. Here are some examples of surface energy. This is our surface energy chart, which I actually pulled from 3M's website. So high surface energy materials, like I said, typically metals, natural materials, and glass. So you have your copper, aluminum, zinc, tin, lead, stainless steel, glass. Mill finish aluminum is a very big substrate that we work with in our industry, and it's very advantageous to tapes and adhesives to wet out on. It has a very high surface energy. Medium surface energy materials are materials between that 38 to 50 dyne range. So a lot of these include, some various wet paint systems, so painted metals, and some engineered plastics like your acrylic, polycarbonate, ABS, all medium surface energy materials. With your low surface energy materials, these are materials that are going to be under that 37 dynes per centimeter level. So it's going to be your polystyrene, your polyethylene blends, your polypropylene, your Kynar paint systems, sometimes even powder coat paint systems. So when you're working with all of these materials and these substrates, it's very important to understand what exactly you're sticking to. A lot of our customers will, tell us, hey, I'm looking to stick aluminum to plastic. Well, is there some sort of surface on the aluminum? What type of aluminum is it? Is it galvanized aluminum? Is it mill finish aluminum, which is just bare aluminum? Is it painted aluminum? And what type of plastic is it? Because that's going to dictate what type of bonding solution we're going to spec in based on what those materials are. And we always spec in a material that will perform on the low surface energy material. So we always, when we're bonding two dissimilar materials together, say you're bonding aluminum, mill finish aluminum to acrylic, we would base that choice off of a product that can bond well to the acrylic, because low surface energy materials that bond well to low surface energy materials also bond well to high surface energy materials. Another important topic when it comes to bonding is the concept of cohesion. So cohesion is basically the the amount of internal strength that a material has. So when we're doing testing to see how the bonding material fails, it's important to get cohesive failure. Or if you're working with a tape, we call it foam split, which you can see here, cohesion or cohesive failure. That means that the strength of the bond on both substrates is actually stronger than the internal strength of the material or the foam, for instance, if it's a foam tape. Adhesion failure is typically a failure. Any sort of, it would be like clean peel adhesive on a substrate when we do the pool testing. This is what we want. This is not what we want to see. That means that the bond was not strong enough to that specific substrate. Sometimes we get a mix of adhesion and cohesive failure, so we can also call that partial foam split when it comes to tapes where you are getting that partial. This can be considered a success in specific circumstances. And then substrate failure. If you're bonding, say, a structural adhesive to a flimsy plastic, that substrate is going to fail before the bond does. So that would be considered a win as well. So substrate failure and cohesive failure are the failure types we want to see that indicate that you have a really good bond to your specific material. Here are some different joint stress types. On the left-hand side, you see different stresses that are very good for tapes and adhesives, and you see some on the right side that are not ideal for tapes and adhesives. I'll go over each stress type. The first one on the left here is shear or overlap shear strength or stress. This is very important as it's very commonly seen in the applications that we work in. So you have your shear stress, which is basically your sliding force. So if you're hanging something up on the wall, that stress downwards, that gravity pull, would be a shear stress type. Tensile strength is basically that pulling force. So if you hang something on a ceiling and that pulling force downwards, that gravity and weight force, that would be an example of a tensile stress. Compression is a pushing force. So anything that's on top, it would be compressing down. All of these are very advantageous stress types for tapes and adhesives. So if you're working on an application that sees shear, tensile, or compression, it's probably going to be a good application for a tape and adhesive. The reason is because in shear, tensile, and compression, the stress is evenly exerted across the full bond line of the tape and the adhesive. So as you can see in these illustrations, the force is distributed across that bond line. Whereas cleavage and peel strength, the stress is distributed right at that edge there. It's not evenly distributed across the bond line. So that's where you're going to have instances of failure, when all that stress is exerted at one specific point and not throughout the bond line. Cleavage and peel are the same exact force. It's that prime force. The difference is cleavage is between two rigid materials, so you have that same force, but it reacts on the bond line a little differently because it's in between two rigid materials. Peel is that same prime force, but between at least one flexible material. So same exact prime force, but again, the bond line is reacting a little bit differently than cleavage because of that flexible material. So applications that see shear, tensile, and compression, good candidates for tapes and adhesives. Applications that see cleavage and peel, not great for adhesives and tapes. So common metals and surface energy. Aluminum is a big surface that we work with in a lot of different markets that we call on. So when we're looking to bond to aluminum and other types of materials, specifically metals, we want to make sure that we know what what's on top of that substrate that we're actually sticking to. So I wanted to go through, some common finishes and paints that we see on aluminum. So you'll often hear people refer to mill finish aluminum. This is just bare aluminum. It's the finish it comes off with off the mill. Very advantageous to stick to with tapes and adhesives. Galvanized aluminum, or there's galvanized steel. Very commonly used in sheet metal and HVAC applications. Anodized aluminum. This is also big in architectural applications. Powder coat and wet paint. Big in a lot of different markets. Powder coat is basically a powder paint that goes into an oven to dry, typically at about 400 degrees for 20 to 30 minutes. There are some adhesives that can be bonded before the powder coat cycle if they want to assemble and then put through the powder coat cycle, so they can withstand 400 to 450 degrees for up to 1 hour. Wet paint, different types of wet paint systems as well. So when we are working with tapes and adhesives, like I mentioned before, we want to really understand what exactly we're sticking to. Because if we're sticking to galvanized aluminum, we're actually sticking to that top layer of that zinc coating. We're not sticking to the bare aluminum. Same with anodized and same with paint systems. And different paint systems carry different surface energies. Acrylic paint systems versus Kynar paint systems. Acrylic is going to be a lot easier to work with. Kynar is going to have a lower surface energy, so we may need to use a primer or need to use a low surface energy material to wet out over that surface.
I'm going to cover the 3 different bonding tapes that 3M has to offer. Transfer adhesive tapes, double coated tapes, and VHB tapes. 3M transfer tapes are just glue laminated to a liner. There is no carrier, and it's 100% adhesive throughout. Since there's no body of this tape's able to wet out on the peaks and valleys of surfaces. The pros to a transfer adhesive tape are they're very flexible and conformable. So when you put them down, since they don't have a carrier, they'll try to wet into the surface better than a double coated tape. Higher temperature resistance is greater for an adhesive transfer tape because you're not dependent on the temperature resistance of the carrier. The cons are the tape is hard to handle since there's no body. The glue can get applied uneven if you're not careful. It's also harder to convert because when the lace slitter cuts into it, it pushes the adhesive on the liner. And on narrow rows especially, the narrow rolls can actually gum up on one side and they become very stringy when you're trying to apply them. Double coated tapes are constructed with a carrier. So you have a carrier such as tissue, polyester, polyethylene, or polyurethane that are coated with adhesives on both sides. The benefits of a double coated tape are the carrier provides structure. It makes it easier to handle because it has that extra body to it, and it's also easier to convert and die cut. Also with the double coated tape, you have the ability to add differential adhesives to it. So you could have one side with acrylic adhesive and you could have another side with a silicone adhesive. The cons of double coated tape are you're only as strong as the carrier that's in the tape. So a polyurethane is going to be much stronger than a tissue paper double coated tape. Also, the carrier could limit the temperature resistance of a double coated tape. With a double coated tape, you do lose that ability to get that deep wet out because the carrier will hold back some of that adhesive from completely wetting out into your surface. Now that I've gone over transfer adhesive tapes and double coated tapes, I'm going to introduce you to 3M VHB tapes. 3M VHB tapes are the best of both worlds for transfer adhesive tapes and double-coated tapes. VHB tapes, or acrylic foam tapes, are a homogeneous blend of acrylic foam and acrylic adhesive. There are many benefits to using a 3M VHB tape. You get the best of both worlds with a VHB tape, where it acts like a double-coated tape, where it has that body that makes it very easy to apply, and it also tries to wet out as a transfer adhesive tape, trying to reach all the peaks and valleys of a surface. It has 300% elongation, which allows it to be stretched 3 times its own body. This is very handy when you're looking at applications that have a lot of thermal expansion or have to deal with wind loads or vibrations. This viscoelasticity allows it to absorb and dissipate energy while being impacted. Some of the cons are, just like a double-coated tape, it's only as strong as its acrylic foam core. We like to consider VHB tape as structural, however, under the definition of 3M, it does not meet 1,000 psi or greater. When VHB tape is applied at room temperature, it reaches 50% wet out in the first 20 minutes. In the first 24 hours, the tape reaches 90% of wet out. At 72 hours or 3 days, the VHB tape has completely wet out and has reached its maximum bond strength. The tape can reach this timeline sooner if it's applied at higher temperatures or used with primers and promoters. But if you apply the tape less than room temperature, it'll take longer than 72 hours to reach 100% wet out. There are 3 types of acrylic foam tapes. You have your very conformable, like your 5952 family. You have your conformable, like the 4941 family and RP family. And you also have your firm VHB tapes. The softer the acrylic foam tape, the easier it can be applied to surfaces and wet out. So as this chart illustrates, the 5952 family can stick to lower surface energies than the conformable 4941 family and RP family, where the 4941 family and RP family, they might require primer 94 or AP 111 to wet out. The general rule of thumb for double-coated tapes and VHB tapes that'll be used as a standalone attachment is 4 square inches of coverage for every pound of dead load. So this is the tape being used to hold something in place, let's just say on a wall. You need 4 square inches for every pound that object weighs, so the tape can handle the static load of that application. Using the same technology as they made VHB tape, 3M developed extreme sealing tape. Extreme sealing tape was designed to go over seams where you'd otherwise use sealant. The key takeaway with extreme sealing tape is, unlike caulking, where you have to wait 24 hours for that seam to cure before you can move on to the next step, extreme sealing tape can be applied immediately, and you have a seal that you do not have to wait for it to cure. This is very beneficial for a trailer manufacturer, because once they put the extreme sealing tape down, they can move the trailer to the next step in the manufacturing process, creating faster throughput. Whereas using caulking, they have to wait 24 hours for that sealant to cure before they can take that next step. There are two items that help prepare the surface for VHB tapes, double-coated tapes, and transfer adhesive tapes. Primers lay down a thin film on the surface that creates a higher surface energy for the tapes to stick to. When you put down a primer, you have to let it flash off so it builds that film. A promoter, on the other hand, is more of a cleaner that helps clean the surface for the tape. The promoter, you wipe it on and then you wipe it off. You don't let it flash off like a primer. AP111 was developed for metals. It's made up of mostly isopropyl alcohol and a 3M proprietary ingredient, or as 3M likes to call it, some fairy dust. This product is 99% isopropyl alcohol, but it's helped use in the cleaning process to create a desirable surface for a VHB tape, a double-coated tape, or transfer adhesive tape to stick to. AP115 silane glass treatment is a cleaner that's used only on glass. It's made up of 90% isopropyl alcohol and 10% silane. Glass in nature is hydrophilic. It allows moisture to collect. By using AP115, it will clear out the moisture, which the isopropyl alcohol does, and then the 10% silane sits in the crevices of the glass, which will repel any water. This makes the glass surface hydrophobic, which is ideal for VHB tapes, double-coated tapes, and transfer adhesive tapes. 3M Primer 94 was actually developed for plastics. Because plastics are harder to stick to, this primer helps create a higher surface energy for tapes to stick to. With painting technology progressing in some powder coats, it was found that 3M Primer 94 actually had to be used in lieu of AP111 in some instances. Primer 94 is an incredible product. It can help tape stick to surfaces that otherwise would not be friendly for VHB, double-coated tapes, or transfer adhesive tapes. However, it is environmentally unfriendly.
3M has 3 different types of structural adhesives. You have your acrylics, your epoxies, and your urethanes. Epoxies were the original 2-part structural adhesive, so a lot of our customers and contacts that we're calling on will refer to a 2-part structural adhesive as an epoxy, but they may not mean that they need a epoxy 2-part structural adhesive. It's kind of like how people just call them epoxies, even though they could be an acrylic 2-part, they could be an epoxy, or they could be a urethane. So just keep that in mind when you're, when you're making calls and going on meetings and working on different applications. So my personal favorite is the acrylic 2-part structural adhesives. Think of them as the teeth. They can really bite through a lot of oils, dirts. They are the least sensitive to surface preparation out of all 3 technologies. So what that means is they will still reach structural strength without any sort of surface prep. With epoxies and urethanes, to reach structural strength, you need to clean, abrade, and then clean again. They also tend to set up a lot faster than epoxies and urethanes, so they'll reach handling and even structural strength a lot faster than the other 2 technologies on the market. And they've got really good impact and peel strength. And there's also options in the 3M acrylic structural adhesive lineup that can be bonded pre-powder coat, so they can withstand, that 400 degree for up to an hour. Epoxies, highest overall strength. Think of them as your muscles. original structural adhesive on the market, best UV resistance, outdoor weather resistance, temperature resistance. It's all going to be the highest with epoxies. But again, tend to require a lot of surface prep to reach structural strength and also tend to set up very slowly. Urethanes, think of them as a cartilage. They are the most flexible out of the three technologies. So they can be a good solution to bond dissimilar materials because dissimilar materials expand and contract when exposed to hot and cold temp cycling at different rates. However, there are some flexible epoxies and acrylics that we would typically push our customers to just because we prefer those types of technologies. We tend to not sell a lot of urethane technologies. Like I said, epoxies are the Cadillac of the two-part structural adhesives, the original structural adhesive, most robust, strongest, best with environmental resistance. Think of them as the muscles. They do require additional surface prep. 3M has 3 different families of structural adhesives in the epoxy lineup. So with the epoxies, there's rigid, flexible, and toughened. Rigid epoxy adhesives have higher tensile but very low elongation. So what that means is they're very rigid. They're not flexible at all. Then you have your flexible epoxies. Lower tensile, so lower strength, but more flexible. Really great for dissimilar bonding, like I talked about before. Metals and plastics, or even different metals and different types of plastics, they're all going to expand and contract at different rates when exposed to the thermal cycling process. So it's important if you are bonding dissimilar materials, you want to find a solution that is able to flex with those different moving rates. So a rigid epoxy, not a good solution for bonding dissimilar materials. Flexible epoxy, good solution for bonding dissimilar materials. And then you have your toughened epoxy. This is a high tensile strength and has very high fatigue and impact resistance. A product called 3M DP 420 is a part of the epoxy toughened lineup. So very high fatigue resistance. And you can click the video below to look at a video demonstrating the strength of 3M DP 420, which is a toughened epoxy adhesive. Acrylics are my favorite. They are a really great go-to. All of the structural adhesives that we stock at TBP are acrylic adhesives. They're really great for a lot of different materials like metals and plastics. Very versatile. They have a fast rate of strength buildup, so they reach handling and structural strength quite quickly, and they require a lot less surface prep than epoxies and urethanes. 3M has a couple different families under their acrylic structural adhesive umbrella. You have your low odor, the 3M DP 8800 series. This is an older technology. It was the go-to for post powder coat metals. So sticking to a powder coat metal, this was 3M's old go-to, but it kind of came short because it didn't have great impact resistance in extremely low temperatures. So I think in the future, 3M is going to slowly phase this product out. And that's why they introduced this new generation low odor acrylic adhesive series. My personal favorite, 3M DP 8700 NS series. This does everything that the 8800 series does, but has great cold weather resistance. So it actually doubles its strength and overlap shear in -40 degrees. So it goes from about 25 to 2600 psi up to 4500 psi in -40 degrees. So really, really great solution. Can bond to a lot of different materials. I will typically lead with this product series. It's available in a 8705, 8710, and 8725. The 05, the 10, and the 25 stand for the open time. So what the open time means is the time you have after you lay the bead of adhesive before you have to make the bond. Okay? And then with structural adhesives, there is time to handling strength. So that is the time it takes to reach handling strength, which is defined as 50 psi in overlap shear. So this is your fixture time. So the time you have to take for the adhesive to kind of set up enough and dry where you can move it down to the next step in the production process. Another important time consideration is time it takes to reach structural strength. So that is the time it takes for the adhesive to set up to 1000 psi in overlap shear. With this 86, 87, and 8900 series, only a couple minutes later, they tend to reach structural strength from handling strength. So if you have, say 8710 reaches handling strength within 12 minutes, in 15 minutes it will reach structural strength. So very, very fast. 8600 series is available in a 10 and a 25-minute open time. Similar to the 8700 series, not as strong in shear and tensile, but is super flexible and has low exotherm. So you can watch that straw video. You can see how flexible the material is. So really great solution for bonding to similar materials that are going to flex a lot. Low exotherm. Exotherm is the heat that's released during the chemical curing process when the two parts come together. So you have your accelerator and your base, or your adhesive and your activator. When the two parts come together during the chemical curing process, they release heat, and that heat is considered exotherm. So why that's important for what we do. When you're bonding thin gauge metals together, or thin gauge materials, and there's heat released, it will expand and then it will contract back to its original shape. It can leave ripples or a dimpling effect on the surface. This is called read-through. So if aesthetics are important, you definitely do not want to spec in an adhesive that has high exotherm if it's a very thin gauge material. DP 8900 series, it's a nylon bonder. It's really great for nylon. I haven't seen a lot of nylon applications in the markets that we call in at TBP, but just know that there's a good solution for nylon. 3M has MMA, methyl methacrylate acrylic adhesives. MMAs are typically very common acrylic adhesives. So Lord has MMAs, Loctite has MMAs, Plexus has MMAs, Sikafast is an MMA. We also sell that. Very common type of acrylic adhesive. They're really great because they're versatile, but they have very high odor and they're flammable. So what's nice about this new generation low odor, 86 and 8700 series, low odor and non-flammable. So MMAs you cannot weld near because it's flammable. They are flammable. They also tend to have high exotherm. So MMAs are not going to be a good solution for bonding those very thin gauge materials. And then you have lastly your low surface energy acrylic adhesive. This is going to be your DP 8010. This product is made to bond to super low surface energy materials like polyethylene, polypropylene, TPEs and TPOs, thermoplastic elastomers, thermoplastic olefins. That's what TPO and TPE stand for. Going back to what I mentioned earlier, I wanted to share these two graphs of surface prep techniques on epoxies versus acrylic structural adhesives. So on the left-hand side in the blue, you have your toughened epoxy, a product like the 3M DP 420 that you saw in the video earlier in this slide. And then you have your methyl methacrylate MMA acrylic in the green, which is a 3M DP 8407 NS type product. Overlap shear on the left-hand side, and then on the bottom, various preparation steps. So as you can see, no prep on an MMA, still reaching 4000 psi. But that toughened epoxy, the strongest epoxy that there is, with no surface prep, it's not even reaching that 1000 psi threshold to be considered a structural adhesive. But then when you go to, abrasion and chemical etching, that's when the toughened epoxy starts to outperform the acrylic adhesive. So if you really need something with a lot of strength, an epoxy is great. but just know that there are some nuances with surface prep to reach that strength. Whereas with an MMA acrylic adhesive or a low odor acrylic adhesive, you're around the same kind of strength or in the same realm with no surface prep all the way up to chemical etching. Same thing on this right-hand graph. You've got your DP420 in blue, and you've got your DP8407 in red. So you have your toughened acrylic adhesive in blue. I'm sorry, toughened epoxy adhesive in blue, and the MMA acrylic adhesive in red. Clean aluminum, you're reaching very high shear strength with the epoxy, but oily aluminum, you are not reaching good strength values with the epoxy. Urethanes, like I mentioned, are the flexible option of the 3 different types of structural adhesives. They can withstand creep within wood. They're kind of like the cartilage, think of them, and they're just good for multi-material bonding. Like I mentioned earlier, we don't sell a whole lot of urethanes, but we do have access to them if need be. 3M's got 2 different families of urethanes. There's semi-rigid and flexible. So semi-rigid is higher tensile but has lower elongation, which is flexibility. Flexible, lower tensile with higher elongation. These also, the 6300 series, so the 63, 10, and 30, also have low exotherm capability, so less read through on the back of the material like we talked about. They're good for bonding composites as well. They were kind of our go-to for a low exotherm solution for thin gauge materials up until 3M released the 87 and 8600 series. So I would typically recommend 8600 series if we do need something that's low exotherm over the 6300 series. Okay, here's an example of read through and why exotherm is important to consider. Talked about it before. Exotherm is the heat released during the chemical curing process of 2-part structural adhesives. This is an example of what happens when you bond a heat-sensitive material or a thin gauge metal. Once the adhesive goes through the curing process and shrinks back to its original size, you can see all of this dimpling here. And if it's an application where aesthetics are important, this is not going to work. Another structural adhesive within 3M is 3M instant adhesives. These are CAs or cyanacrylites. CA is sometimes a little easier to say. These are really good solutions for very small surface areas, so ideal for 1 inch by 1 inch and under surfaces and applications. They tend to set up really fast. So think of these as kind of like a super glue. Thread lockers, 3M also has thread lockers. These are adhesives basically applied to threaded fasteners to help provide a tight lock and seal and help prevent loosening due to stress loads, vibration, and shock. Now, some of these, there's different thread locker types. Some are permanent and some are removable. The PR100 is a go-to CA for us. Like I said, these are considered super glues. They have very fast handling strength, good solution for bonding small surfaces. The PR stands for plastic and rubber, so it bonds to a lot of different plastic and rubbers. There's also a CA primer that can be used before applying CA that makes these CAs bond really well to silicone materials. So think of these as like really good plastic and like rubber and elastomeric material bonder. So like I mentioned before, 3M has thread lockers. They basically work when air is not present. They're really great for, bonding bolts to machinery, to lock that threaded fastener. With 3M's lineup, the red is permanent, where the blue is a removable solution if they ever have to, access that fastener. This is a unique product within the 3M structural adhesive portfolio. It is a 1-part. It's almost like a structural hot melt. So it comes in a tube like this. It can be applied with a pneumatic applicator. It's a very specific one. It's called EZ250 applicator. It bonds to a lot of different surfaces, including woods and plastics, and it's 100% solids, so no VOC content, so very environmentally friendly. It is dispensed at a hot temperature and then cures very quickly. It is a really good solution for bonding wood structurally. So instead of using wood glue that sets up really slow, or wood glue with fasteners, it will eliminate the fastener step. It will bond to wood very, very quickly and very fast. So we call these non-structural adhesives, but basically liquid adhesives that are either in a roll-on form or a spray-on form. So these are available in aerosol cans, cylinder adhesive, so that would be like a cylinder spray, and bulk. Bulk would be 5-gallon pails, 55-gallon drums, or totes. So these are 3M aerosol spray adhesives. They're very portable. They don't require a lot of skill set, so anyone can use these properly. You don't need skilled labor to use aerosol spray cans. Super easy. They're a really good solution for small surface areas like 2 feet by 2 feet and under. Within the spray adhesive portfolio, the next size up would be your cylinder spray. This is it's available. The picture here is showing a large size cylinder, which is right around 39 pounds, about the size of your propane tank for your gas grill. Very portable, pretty easy to use, more economical than aerosol cans, less change out, less waste, more precise spray pattern because it comes with a hose and a cylinder. Pretty easy to use. Don't have to worry about throwing out a ton of aerosol cans. They're also available, like I said, this is the large size cylinder. They're available in an intermediate size cylinder, which is very tall, like 140-pound cylinder, which are also referred to as torpedo. And then a jumbo size, which is about 250 pounds, so very tall and wide. They tend to have a higher solids content than aerosol cans, so more adhesive, you're getting a little more bang for your buck. And 3M has a cylinder return program on intermediate size and up. Cylinders, you can actually schedule a truck free of charge to pick up and recycle the canister back to 3M. So you don't have to worry about, trash and getting rid of the material. With bulk adhesives, you're going to get the most bang for your buck cost-wise, so most square foot coverage per cost. Most economical, like I said, great for rolling or brush on applications. You can spray bulk adhesives too, but it does require some sort of specialty equipment to do that. And typically on the specification sheet for the product, it will kind of guide the customer on what 3M would recommend for equipment. You can also work with Don and myself to help facilitate that. There is some automation application engineers at 3M where they can point us in the right direction as to what they would recommend for a specific product and a customer specific application.
3M has a line of sealants and adhesives known as Powerline. There's 2 types of products that 3M has in their sealant and adhesive line: polyurethanes and silane modified polymers known as hybrids called SMP. For general purpose applications, 3M has the 540 sealant, the 550 FC adhesive sealant, and the 560 adhesive sealant. For applications that have a higher need for UV resistance, 3M has the 740 UV sealant and the 760 UV adhesive sealant. For more demanding applications or marine applications, 3M has the polyurethane 5200 adhesive sealant and their SMP version, the 3M 4000 UV adhesive sealant. To help improve customers' throughput when using their transfer tapes, 3M developed the ATG series. The ATG series has several tapes that work on multiple surfaces. To use the ATG gun, you put the roll of tape in it. You then put the applicator to the substrates that you're going to use. You pull in the trigger and then you slide the applicator until you're done applying the tape, release the trigger, and then you can move on to the next substrate. To compete against Velcro, 3M developed hook and loop, which utilizes a male and female part that marry together for various applications. 3M hook and loop comes in 3 different forms: no adhesive, acrylic adhesive, and rubber-based adhesive. The no adhesive form actually works for people like us because we can actually laminate our own adhesive on it. A higher step up from hook and loop is dual lock. Dual lock uses a polypropylene mushroom system that's primed and then applied to VHB tape. It creates a very strong bond, which is very similar to VHB tape. However, the stem system allows that product to be removed and then reapplied. All the mushrooms are one universal stem system. Unlike hook and loop, there are no male or female parts. It's just one type of mushroom construction that come in 3 different types depending on the amount of mushrooms you need per square inch, or the removability of that product. The more stems per square inch, the harder it is to remove that bond.
3M also has hot melts, similar to the PUR, 100% solid, so no VOCs. You get immediate handling strength. Really good solution for bonding wood, plastics, foam, cardboard, light duty, lightweight materials. I've seen them very heavily used in furniture and woodworking industry on point of purchase as well. And then there's some options for low melt versus hot melt. Low melts are dispensed at a lower temperature than hot melts. So if you're working with heat sensitive materials, it might be better to look at a low melt option. So 3M has a couple different types of applicators for low melts and hot melts, depending on the different size that you get the sticks in. There's longer sticks, shorter sticks, pellets. So these applicators are specific to the size pellet that your customer is looking to use. So, high volume, medium volume, low volume. 3M 6111 is an interesting product. It is a sprayable grade hot melt, so it does require some equipment to do this, but if you watch the video, you'll get a better idea of how it works. Just anything that you're looking to, kind of increase throughput. This would be, instead of laying a bead, you can do a spray pattern and get a wider, area coverage in a shorter amount of time. This could be a good solution. Some of 3M winning applications: panel assembly, large surface lamination, mounting and trim assembly, small joint assembly, gasket attachment, and then sealing and potting. Panel assembly, you're going to have some good solutions with VHB tape, structural adhesives, even some adhesive sealants. Large surface lamination applications tend to be utilizing a larger surface worth of tapes and adhesives, so like wide width tapes or spray adhesives. Mounting and trim, really good solution for tapes as well. Small joint assembly, there's typically not a lot of surface area to work with, so that might require some sort of liquid solution. Gasket attachment, we actually can do that in-house, where we can provide our gaskets and laminate various thin bonding tapes onto those gaskets, or maybe even provide an instant adhesive, like I mentioned earlier, for attaching these elastomeric gasket type materials. And then sealing and potting, good solutions for adhesive sealants and some structural adhesives for potting. Potting is typically used in the electronics industry. We tend to not really sell a lot of adhesives for potting, but we do have access to some. Moving along here to 3M single coated tapes. The 2 different types of tapes we're going to be discussing are MRO type tapes. These are more general purpose, operational type tapes that are typically used within the production process. So MRO stands for maintenance, repair, and operation. and then also specialty type single coated tapes. The first MRO general purpose masking tape is 3M 101 Plus. This is part of the 3M Masking Made Simple line. So there's 101 Plus, 201 Plus, 301 Plus, 401 Plus, and 501 Plus, which I'll be discussing each one in depth on each slide here. But this is, the most general purpose, most economical version out of the Masking Made Simple portfolio. It's just a general purpose masking tape made of crepe paper, so it makes it very easy to tear. It's really made for like very general purpose indoor light duty type applications. 201 Plus is the next series in the Masking Made Simple line from 3M. Again, still kind of general purpose, same crepe paper backing, but it's a little bit more engineered than the 101 Plus. It's a step above, so it can be for light to medium duty type applications, bundling, sealing, holding. You can write on it, so if you want to, label specific materials and, rip off once the manufacturing process is done, it could be a good solution for that. It can withstand a little bit of a bake cycle, 200 degrees for up to 30 minutes. And it has a specialty solvent-free adhesive that can remove cleanly in one piece. Next we have 3M 301 Plus. So this is a higher performance smooth crepe paper masking tape. So it is an entry level to a painter's tape. So 101 and 201 Plus typically are not used for paint masking. 301 Plus and above can be used for paint masking. It can withstand a little bit higher temp, 225 degrees for 30 minutes, and it has that same solvent-free adhesive system that can remove cleanly in one piece as the 201 Plus does. I see this material a lot used in the transportation truck trailer industry. Moving along, we have 3M 401 Plus. This masking product is a step above the 301 Plus, so it can withstand 250 degrees for 30 minutes. Can write on as well, can be used for bundling. Really, the main difference is it has better holding strength. It has that little bit higher temp resistance and has sharper lines than the 301 Plus for paint masking. So if you're looking for paint masking and needs some critical line masking, this could be a good go-to for that. 3M 501 Plus is the highest engineered masking tape out of the 3M Masking Made Simple portfolio. It's going to have your highest temperature resistance at 300 degrees for 30 minutes. Similar characteristics to the other few that we mentioned, can be used for bundling, can write on. Typically see it in aerospace and transportation industries where you need that high temperature resistance and that critical paint mask sharp line. Now we have our 3M 2090. This is your standard blue painter's tape that you see in a lot of different applications for paint masking. It can be purchased from Home Depot. When we made the slide deck, it was before 3M introduced a new product called 3M UV grain masking tape, which is basically the industrial version of 3M blue painter's tape. So both have that 14-day UV resistance exposure, medium tack level, really good for paint masking type applications.
The 3M 5903 is a great outdoor masking tape. It can be used in a variety of applications. You can use it as a 30-day UV protection film. You can use it to hold broken glass in place while you remove it. You can use it for bundling. The product's great because it's also hand tearable. You don't need scissors. You can also write on it to label things. And overall, it's probably my favorite masking tape. 3M's go-to masking tape for powder-coated applications is the 8992. It has a polyester backing with a silicone adhesive. It can handle up to 400 degrees for 1 hour in a powder coat oven. It can also be used in flash breaker and bag sealing applications that will see similar heat. If you need to die cut it, it also comes in a linered version, the 8992L. For general purpose foil tape applications, the 1520 CW is our go-to. It can be applied at negative 10 degrees Fahrenheit. It has a UL 723 rating. It's hand tearable, and it's designed to go over irregular surfaces. For more demanding applications than the 1520 CW, there's the 1525 CW, which is an FSK tape. It's composed of foil, scrim, and craft paper. It's ideal for curtain wall insulation. It can get applied down to low temperatures like the 1520 CW, and with the scrim, it can handle stress where the 1520 would otherwise tear and fail. For duct applications, the 1581A foil tape is our go-to. It has a UL 181A rating and UL 181B rating, which is needed to cover the seams in HVAC ducts. It is labeled so code enforcement officers can walk through a new building under construction and see that rating so they can sign off on it. The key with those UL ratings is it helps block out smoke. So in the event of a fire, the smoke can't penetrate the duct and spread throughout the whole entire building. It is also mold resistant.
Thank you for going through our 3M internal training presentation here with Don and myself. Appreciate your time. Please reach out to Don and myself with any questions on anything that you've learned in the presentation, or if there was anything that you wanted us to elaborate on. We're here to help. Thanks.